Hi guys, a very good evening everyone. Welcome to the session. Welcome to the GATE previous year questions, discussions, the solutions, the approach, the methodology, the exam patterns, everything we are discussing here. Okay, so I've already completed it for digital. Okay, and today we are going to discuss up, just a second. All right, yes. So we've already done this for digital electronics, okay, for EC also, for EE also, for computer science also, okay. And digital, because it's a common subject, I always suggest you to solve questions of multiple branches only, right? Now today we are going to discuss the signals and system. Today we are going to discuss signal and system, and first we will be today discussing the previous year questions 2021, 2022, 2023, okay. For these 3 years, 2021, 22, 23, we'll be discussing the questions today, because recent year gives you the more idea about the weightage and the analysis and the difficulty levels. Okay, and we'll be discussing EC questions in the next session that I'm going to take it on Monday. We'll discuss the EE questions also, so that we are bifurcating it branch wise, but again being a common subject, signal and system for EC EE common. Okay, you should attend both if you are looking for actual practice. Okay, even instrumentation students can watch it up. This is a regular introduction about me that you're aware. Let's get moving ahead now. Okay, so guys, for all the PDFs, like last digital PDFs also I have shared, and any other doubts for other important concepts or update about the exam and PSU notification, everything, you can be also connected in my Telegram group. Okay, name mentioned here. I'll also share you the link in the comment box after some time in the chat box. Right, the UPSC 2023 mains results have been declared, and BYJU'S exam prep is bringing you the free mock interview. Already started, okay. Right, so free mock interviews with our expert panel, okay, to give you a real interview type of feel before going to the interview, to feel the interview, feel like actual interview before your real interview. Okay, so if you're one of the student qualified the mains and looking for such interview guidance session by the experts, okay, you can just share your result. There is a link in the description. Open and share. The team will coordinate you and book your slots accordingly. Now the time for the questions. Let us get started quickly. Here it is. Okay, consider a system with the input xt and the output yt. Okay, and yt is given as x of e power t. The system should be what? 2023 EC 1 mark question it is. So topic by topic bifurcated. Okay. So output yt is x e power t. Whether the system, we have to check two things: causality and time invariance of the system. The causality and the time invariance of the system. Okay, so what does the causality say? Is very simple logic. If you take t equal to 0, right, what is going to be y0? Y0 will be equal to x of e power 0, but e power 0 we know is 1. Okay, so you are calculating the output at t equal to 0. You are calculating the output at the t equal to 0, and to calculate the output at t equal to 0, you need the value of the input at t equal to 1. Okay, that is the futuristic value, and such a system is non-causal. Okay, when the output depends on the future values of the input, it cannot be causal. It is a non-causal case. Okay, okay. Now this is one simple example to prove non-causal. Regarding to the time invariance, okay, number one, in the time invariance, what you need to do? Okay, a time shift in the input should produce a similar time shift in the output. Okay, I hope the theory part you know. Okay, the time shift in the input should produce a similar time shift in the output. So if I want to check the time invariance, let me first calculate a output. Let me first calculate the output which is due to delaying the input. Right, good evening Bhanu, good evening Dreamer, which is due to delaying the input. The input is x e power t. Okay, the relation is x e power t. If I delay the input, it should be looking like e power t minus some delay t naught. Okay, but on the other hand, so I have shifted the input by t naught, I have delayed the input by t naught. And the other hand, if I provide the same delay, to the output directly, okay, see, I have y of t is equal to x of t minus t naught. Okay, one is the output due to the delayed input. Okay, now another one, let me produce a similar delay in the output. Let me calculate y of t minus t naught, and let's say that output is y2t, and y of t minus t naught clearly kitna hoga? Oh sorry, here I wanted to write yt is equal to the given relation x e power t. So y of t minus t naught, x of e raised to the power, kitna hua ye? X of e raised to the power, t will be replaced by t minus t naught. Now are these two same? No, they are not the same. Okay, good evening Ganesh. They are not the same. So definitely y1 is not equal to y2. Okay, y1 does not equal to the y2. So the system is time variant. The system is time variant. Clear? So it is non-causal as well as time varying. So correct answer to be marked is option number B. The correct answer to be marked is option number B. Right, Aji? Any doubts you can ask me. Next question, moving ahead, here it is. The outputs of 4 systems S1, S2, S3, S4 corresponding to the input signal sin t, okay, for all time t are shown in the figure. 2022 EC 2 marks question. Let me also add on that it is a MSQ question asked by the gate. Okay, good evening Sheetal. Okay, it is a MSQ question asked by the gate. Okay, multiple select question, so one or more than one option may be correct. Okay, so there is an input signal, please pay attention. They have given you an input signal that is known as the sin t. Okay, based on the given information, which of the 4 system is or are definitely not LTI? Which is or are not LTI? Okay, it's a good question. So if I talk about the system S1T, see, if I talk about the system S1T, my input XT is what? My input ST is the sin t. Okay, now output here. For the first system, output, okay, is sine of minus t. Okay, sine of minus t. But देखो, there are 2 possibilities here. Sine of minus t is also equal to minus sin t. Is also equal to minus sin t. That means for the first system, output may be, I'm not sure, output may be sine of minus t. Sine of minus t means t replaced by minus t. So it may be x of minus t, because this is the output for one particular input, right? Or the output may also be equal to, because it is sine minus t, which is minus sin t, which is equal to minus xt. Okay, now guys, you should be aware that, okay, time scaling or time folding, whenever it is come, the system is time variant. Okay, but when it is amplitude scaling, yt is equal to axt, whatever may be the value of a, yt is equal to axt, that is always linear and time invariant also. Okay, so this system may be LTI, may not be LTI. Which of the following are definitely not LTI? That we have to talk about. Okay, now let us come to the second case. What is y2t? That is sine of t plus 1. That means it is x of t plus 1. Time shifting doesn't affect the linearity or the time invariance. Okay, so this is definitely LTI. Okay, this is definitely LTI. Which of them are definitely non-LTI? वो निकालना है ना, हाँ, तो this one is LTI. अच्छा, let us go to the next case. Okay, third case, y2t, okay, is sine 2t. That means it is scaling the input. It is scaling the input x of 2t. Okay, now time scaling, as I just told you. Okay, time scaling. This system will be linear but not time variant. Okay, so it cannot be LTI. Okay, fourth case, for sin t it produces the output. What? It produces the output sin square t, matlab x square t. Okay, and square, it is non-linear. This will be time invariant, but this is non-linear. Okay, so which of the systems are definitely non-LTI? Third and fourth are. The third is definitely not time invariant. The fourth is definitely not linear. Okay, so multiple select question hai. Okay, option number D, option number C. Excuse me. Option number C and option number D, both are correct. The option number C, option number D. ठीक है? हाँ, Hufaiza, depends. देखो, अब से start करना, that is not a big problem. Yeah, but from now on also, if you fix कि आप dedicated time दे सकते हो, okay, full-fledged preparation कर सकते हो, then you can score good as well. Not only average, but you can score good. Okay. Many students started the preparation 3-4 months earlier, but अगर अभी वो केवल they are just giving 1 hour or 2 hour for gate preparation at this point of time, so they will also not get the good score, na? Okay. So yes, you can do it also now if you are dedicated for the upcoming time. Okay, the second one is LTI. First one may be or may not be LTI, but third and fourth definitely not LTI. So that's what they are asking. Which of them are definitely not LTI? ठीक है जी? चलो, done है. Next question, guys. This was MSQ EC 2022 2 marks question. Next, here it is. For a unit step input UN, a discrete time LTI system produces an output signal 2 delta n plus 1 plus delta n plus delta n minus 1. Let yn be the output of the system for the input half un. What is the value of y0? Okay. What should be the value for y0? Output of the system for a given input. Okay. How do you calculate output in general? Okay, we calculate it by input convolution with the impulse response. Okay, convolution with the impulse response. But am I given the impulse response? Actually not. I'm not given the impulse response here. Okay, input is given to me. Okay, this is the input half power n un. What is the impulse response? For the unit step input, a discrete time LTA system produces the output given to you. This is the output for step input. Okay, what is this? This is the output for the step input. Normally we write it as SN, known as step response. इसको क्या बोल देंगे? इसको बोल दीजिए step response. Okay, just call it as what? Just call it as the step response. Okay, just a second. Just call it as what? It is a step response. Now, what is the relation between the impulse response and step response? Okay, the impulse response and the step response. Step response is given by summation of hk from k equal to minus infinity to n, or the impulse response is given by the difference, the first difference of the step response, Sn minus Sn minus 1. It is given by what? It is given by the Sn minus Sn minus 1. Clear, everybody? So we can calculate Sn minus Sn minus 1. What is the step response given to me? 2 delta n plus 1 plus delta n. Okay, plus delta n minus 1. So dear students, what should be the value of S of n minus 1? Okay, that should be, replace n by n minus 1. Replace n by n minus 1. So n minus 1 plus 1, सिर्फ n बचेगा, plus delta n minus 1 and plus delta n minus 1 to n minus 2. And now when you subtract them, what is going to be the impulse response of the system? So see, let me start 2 delta n plus 1. Okay, then delta n minus 2 delta n. So let me write it as minus delta n. Okay, delta n minus 1 minus delta n minus 1. This is purely cancelled. Okay, and then minus delta n minus 2. Subtract हो रहा है तो minus delta n minus 2. Right, everybody? So now I have the impulse response and I can now talk about the output. Okay, don't worry, it's not going to be a lengthy convolution. You might be thinking, sir, convolution se lengthy hoga. No, it is going to be simple only, because only we need the value for the y0. Okay, so let us come, okay, to the point. Yn is given by the xn convolution with hn. Okay, x of n convolution with what? Convolution with hn, that is given by 2 delta n plus 1. A simple property of convolution with impulse. Convolution of a signal with unit impulse signal replicates the signal. Okay, please do apply this property. Okay, so what should be the output yn? What should be the yn output? It is 2 is common constant. Xn convolution delta n plus 1 should be x of n plus 1 minus xn convolution delta n xn minus xn convolution delta n minus 2 x of n minus 2. Convolution with impulse and then the time shifting also applied correspondingly. ठीक है जी? Now put down what is the value of xn. अच्छा, forget. We only need y0. Now y to put down the value. Okay, directly write down n equal to 0. So twice of x1. Okay, minus x of 0 minus x minus 2. तो कितना आंसर होगा? Let me separately write down xn for your memory. Xn is given as half power n un. Okay, now since unit step is involved, unit step will exist for n greater than equal to 0. Okay, so n equal to minus 2, ये तो 0 हो गया. x1. So if you put n equal to 1, you get half power 1. Minus x0. If you put n equal to 0, you get half power 0, which is 1. And third part is 0 only. Okay, so 2 and 2 cancelled. 1. Half power 0 is also 1. Final answer 1 minus 1 cancelled. It is the 0. It is a good question. Okay, it is a good question, testing your fundamental properties. Okay, testing your fundamental properties. The correct answer is 0. The correct answer is equal to what? It is equal to the 0. The correct answer is equal to the 0. Done, hai ji? Cool. Next question then. Okay, next question then. Okay, next question, 2023 EC 2 marks. Okay, this one is relatively easy. Okay, let x1t is equal to u, t plus 0.5 minus u, t minus 0.5, and x2t is shown in the figure below. For yt is equal to x1 convolution x2. Okay, integral क्या बोलेंगे इसे, integral minus infinity to infinity yt dt. Okay, integral of a signal is area under the curve. Okay, is area under the curve, area of yt, but yt is the convolution. So whenever two signals are convoluted, what is the resultant area? It is the multiplication of individual area. Okay, since yt is x1 convolution x2, okay, this should be finally equal to what? Area of x1t multiplied by the area of x2t. Whenever two signals are convoluted, their areas are multiplied. That is the important property of the convolution. If you know, that is easy. Otherwise, you start convoluting and solve, that is lengthy. It depends what approach you follow, but you can make the question lengthy or you can make the question difficult. ठीक है, तो area of x1t into the area of x2t. चलते हैं आगे की तरफ. x1t और x2t ये लिख दिया मैंने. Now, what is the area of x2t? Okay, what is the area for x2t? Okay, it has an impulse, unit impulse. This represents area 1. Okay, plus it has a rectangular portion. The area is height into base. Height is 1. Base is equal to 2. Plus again the unit impulse with the area, that is equal to 2. Okay, so this is 1 plus 2 plus 2, that is equal to 5. So area of the x2t signal is 5. What about the x1t? x1t is ut plus 0.5. चलो बना लेते हैं. इसमें भी थोड़ा सा ही पेन है. Okay. Whenever two unit step signals are subtracted of same amplitude, you should get a rectangular signal, and that is why you can easily calculate its area. Correct. U of t plus 0.5, t plus 0.5, that means there is a unit step signal left shifted started from minus 1.5. Okay, minus ut minus 1.5. So there is another step signal which is right shifted and started from 1.5, and when both subtract 1 minus 1, 0 hoga na. Okay, so this is 1. Okay, the second step signal starts from here and that is also 1. So for this portion, what should be the result? For this portion, 1 minus 1, I'm not drawing two different graphs, yahi pe overlap kiya hai. So when you subtract, this is 1 minus 1, but here, this is only the signal existing 1 and this is 0. 1 minus 0 will be 1. Okay, so there will be the signal 1 left. There will be the signal 1 left. Okay, up to the 1.5. Okay, this is what is the given signal x1t and its corresponding area, rectangular pulse you have got. So height is multiplied by the base, which is equal to 3 units. 3 units. Okay, so now what is the area of x1t? 3 multiplied by area of x2t, निकाल दिया हमने 5. So correct answer for the question is 1550. Very simple question, 2 marks. Again, it is simple if you know the correct properties. Okay, ठीक है. Yes, currently it's LTI system, Ganesh, you can say. If you go chapter, well, the basics, then LTI system, then Fourier and etc. Accordingly, I have arranged the question. Okay. But I'll make sure all the questions, each and every question of the last 3 years, 2021, 22, 23. Okay. Of electronics is discussed today. Electrical questions we will discuss Monday, but you should solve all. Common subjects, hai? Okay. Yeah, if there's any difficulty, Ganesh, let me know the doubts. चलते हैं next question की तरफ. Okay, 2022 EC 1 mark question. If x1t is equal to e power minus t and x2t is ut minus 2. Okay, and if yt denotes the convolution of x1t and x2t, then limit t tending to infinity yt. Now think whether you should apply convolution or what you should apply here. Try to think. Okay, yt is equal to the convolution of x1 and x2. It is the convolution of x1 and x2. Okay? Dear, now you are calculating the limit t tending to infinity yt, final value of the signal. So why can't we apply final value theorem to make the process simple? But to apply final value theorem, I have to go to the S domain, Laplace domain. Okay, so what will I do? I will take y of s, and that is given by x1s multiplied by x2s. Ys is given by the x1s is multiplied by x2x, because convolution in time corresponds to multiplication in the S domain. What is the x1s now? Okay guys, very simple. E power minus t ut, Laplace transform 1 upon s plus 1. Okay, for the second signal, ut minus 2. What is the Laplace transform for ut? 1 upon s minus ut minus 2 time shift property. For ut it is 1 by s, ut minus 2 time shift produces exponential term, okay, e power minus 2s. It will produce a phase term, that is e power minus 2s. Done, eh? Okay, so what is the ys? If you simplify this, you are going to get 1 minus e raised to the power minus 2s, denominator mein s into s plus 1. Okay, now let me apply what? Now let me apply the final value theorem. Limit of t tending to infinity yt is given by limit of s tending to 0 s into ys. Okay, provided all poles are in LHP or maximum one pole at origin, so that condition is satisfied here. There is no RHP pole or there is no imaginary poles. Okay, even at origin there is one pole which is allowed maximum. Okay, so now, okay, I'm just going to solve it. Limit s tending to 0 s into ys. Ys is obtained as 1 minus e power minus 2s upon s plus 1. So very clearly s has got cancelled. There will be s to s cancellation done. And then your answer is s tending to 0, 1 minus e power minus 0 divided by 0 plus 1. But 1 minus e power 0 is 1. Okay, so 0 by 1, final answer is 0. Correct, Bhanu, the final answer is 0. Done, hai ji? The final answer is what? The final answer should be equal to the 0. Should be equal to the 0. The final answer should be equal to the 0. 2022. Okay, 1 mark fundamental question on final value theorem. Okay, we shall move ahead to the next question then. Okay, 2023 current year 1 mark, you can say a knowledge based question. Knowledge means if you have studied all the Fourier spectra, then you should be able to answer it. Okay, table below match the signal type. Okay, this is the signal type given with the spectral characteristics. These are the spectral characteristics given. Okay, if a signal is continuous and aperiodic. Okay, for continuous domain you do the continuous Fourier analysis, but if it is continuous what Fourier analysis you do? Fourier transform. You calculate x omega. Okay, you calculate x omega, right? Manu, the conditions are all the poles must be in the left half plane with at most one pole allowed at origin. Okay, that is the condition to apply final value theorem. All poles in LHP, and if there is a pole at origin, that should be maximum 1. Okay, no more pole at origin, yeah, no complex, no imaginary poles and no RHP poles. If any of these conditions are exist, final value theorem cannot be applied. Okay. Okay. You can watch my class. I have already put a class, initial and final value theorem for Laplace transform. Okay. So today we are focusing on the question practice of previous years. Every topic you just find initial and final value theorem, you find my name, you will get all conditions of initial value theorem also, final value theorem also, and even with the proper conclusions there. ठीक है, उसको find कर सकते हो आप same YouTube channel पे. Okay. Then continuous and periodic. Still it is continuous. We will find the Fourier transform. But guys, for the periodic signal, what is the nature of the Fourier transform? What is the nature of the Fourier transform? देखो यहाँ पे क्या होगा? Okay, continuous and aperiodic के लिए what it is going to be? Okay, the Fourier transform will be continuous only. Okay, but whether it will be aperiodic or periodic, whether it is aperiodic or periodic, it is aperiodic. It is continuous and aperiodic. Okay, this is going to be matched with A. This is going to be matched with A. Okay, for continuous and aperiodic. Okay, but for continuous and periodic, okay, what is the Fourier transform for periodic signals? What should be the Fourier transform for the periodic signals? Just a second. What should be the Fourier transform for periodic signals? If it is continuous periodic signal, the Fourier transform ultimately gets coming by the formula. It turns out to be what formula after solving? It turns out to be formula, okay, summation Ck delta omega minus k omega naught for all the values of k. 2 pi summation Ck delta omega minus k omega naught. It turns out in the form of impulses. That means whenever we draw this, dear, whenever we draw this Fourier transform for continuous periodic signal, okay, see what can be the samples in it. Okay, what can be the samples in it? 2 pi C0. Suppose you take C0. Okay, so delta omega. Delta omega means origin pe. Okay, means origin pe. Okay, this will be given by 2 pi C naught. Okay, k equal to 1. So delta omega minus omega naught. There will be another impulse. Okay, at omega naught. But its area, sorry, it's an impulse. Its area is further going to be 2 pi c1. Similarly, at 2 omega naught, you can get another impulse, but the area of the impulse will depend on the Fourier series coefficient. Okay, etc, etc, etc. So definitely, what is the Fourier transform? It is discrete. Okay, it is discrete. It is not continuous. But is it periodic? No, the values do not repeat. The values can be anything at random. So for this one, it should be discrete but aperiodic. Okay, it should be discrete but aperiodic. It should be what? It should be the discrete and aperiodic. C match hoga. Okay. Now for a discrete and aperiodic signal like xn, you calculate the dtft. Okay. Okay, here you calculate what? dtft. Okay. Represented as x omega. Okay, dtft x omega. X omega is a continuous function of frequency. That is why we discretize and calculate dft. But actually, dtft is a continuous function of omega, but it is always periodic. dtft is always periodic with the period 2 pi. Okay, so it is continuous and periodic. It is continuous and periodic. इस पे B match होगा. And last one, discrete and periodic. For discrete and periodic signal, you calculate the DFT, and the DFT is also discrete in the K domain, and it is periodic. The DFT is also always periodic. So it is discrete and periodic. इस पे D match होगा. इस पे D match होगा. Now you can match the option. Okay, it should be A C B D. It should be A C B D. Option number B. The very correct answer should be the option number B. Done है जी? ठीक है, option number B is very correct. Let us move ahead to the next year. Okay, now this is what? This is like if you have studied signals thoroughly, this is a factual question for us. This is just an information and knowledge based question for us, 1 marker. That is why it is 1 marker. ठीक है, next question. Come up here. 2021 EC 2 marks, a good property question. देखना यहाँ पे अच्छी properties apply होंगी. The exponential Fourier series representation of a continuous time periodic signal xt is given to you. Okay. The xt is given to you. Sorry, this has to be xt. I think it's a typo error. It's a small xt. Summation ak e power jk omega naught. We know how the Fourier series is written. This is a regular Fourier series representation where omega naught is the fundamental angular frequency and the coefficients of series are ak. The following information is given about xt and ak. Okay, the signal xt is real and even and having the fundamental period of 6. Okay, the average value of xt is equal to 2. What do you mean by this average value? The average value of xt is given by the Fourier series coefficient C naught. Okay, or let me call it as A naught, whatever you call it as. Okay, let me call it as A naught here. They're calling it as AK. The average value, okay, is also given by the DC component A naught. So that means A naught ka value 2 hai. Okay, what is this? The A naught is equal to 2. Okay. Then AK information is given for K less than, for 1 less than equal to K less than equal to 3, AK will be K. Otherwise for K greater than 3, it should be the 0. It should be the 0. ठीक है, तो यहाँ पे आ जाते हैं. If I use the third information, okay, I can say that A1 equal to 1, A2 equal to 2, AK is equal to K, right? A3 equal to 3, but A4 and A5 etc. all of them will be 0. Okay, for K greater than 3 it will be 0. But now the signal is real and even. Okay, signal is real and even. Okay, if the signal is real and even, guys, what is the property? Okay, the Fourier series coefficients are also real and even, right? The Fourier series coefficients are also real. Okay, of course they are given to be real, but they are also even. That means A minus 1, वो भी even symmetry follow करेंगे, will be 1. Okay, A minus 2 will be equal to A2, that is equal to 2. A minus 3 will be equal to A3, that is equal to 3. Similarly, A minus 4 and A minus 5, all of these would be 0. All of these would be 0. Clear? Okay. ठीक है, done है. Now, what is the average power of the signal? Ultimately, the question is taking you towards the power, towards the Parseval theorem. Okay, the average power of the signal. Okay, the average power of the signal. Okay, the average power of the signal, which is calculated by basic formula 1 upon T integral over one time period. Okay. 1 upon T, okay, integral over one time period mod of x square T dt. This is one of the basic formula. Okay, energy in one time period divided by time period, ऐसा भी बोल सकते हैं. But eventually applying the Parseval's theorem. This is based on the Parseval's power reserve theorem, and based on the Parseval's power theorem, the energy is also given by, in the Fourier domain, summation of mod ck square for all values of k. Okay, summation for mod ck square. So what is the time average Poynting vector? Summation of ck means ak here, sorry. I have a habit of calling Fourier series coefficient as ck. No problem, here it is ak. Here it is what? It is equal to ak. So what is the time average Poynting vector? Okay, yeah, 1, 2, 3. Okay, then 1, 2, 3. And then what is the c naught? C naught is equal to 2. Okay, so I have how much? 1 square. Okay, 1 square be 2 time aega. 2 square, that is also 2 times. 3 square, that is also 2 time. Okay, and then you have the 2 square. That is what actually the a naught square. Okay, the DC component. This corresponds to a naught. Okay, this corresponds to a1. This corresponds to a2. This corresponds to a3. All other are 0. Why 2? Because a minus 1 has having the same value. So directly into 2 kiya. So this is equal to 2. Okay, then this is 8. This part is equal to 18. Then finally 4. Okay, then finally 4. So 32. Okay, 32 watts of power the signal is going to contain. The time average power should be the 32 watts here. Good question. 2021 2 marks, property based, good question. 32. Hanji, done hai? The correct answer is what? It is equal to the 32. Okay ji. Next question then. Guys, what is the Fourier transform for e power minus t square Gaussian pulse? Direct 2023 1 mark direct formula question. Okay. What is the Fourier transform for e raised to the power minus at square? It should be given by the formula root over of pi by a e raised to the power minus omega square by 4a. Right, ji? So just apply the formula. If it is e power minus t square, that means I have to put a equal to 1. It should have the Fourier transform root over pi, a की जगह 1 रखा, e power minus omega square by 4, tick mark the correct answer, go to the next. Root pi e raised to the power minus omega square by 4. Root over of pi e raised to the power minus omega square by 4. E raised to the power minus of omega square by 4. Done hai? Chalo. Next question. What is the Fourier transform of the signal t upon 1 plus t square whole square? 2022 EC 1 mark, but this is a slightly better question. Previous one to direct formula tha. Okay, come on. Solve it up. By the time, let me take the match updates. What it is? Oh, we are almost into the winning zone. After starting the class, मैं अभी पहली बारी देख रहा हूँ. 11 runs needed in 17 balls. Who is the 5th wicket down? Okay, Sky is out. Alright. Oh, he had 50 also. Just now he's out. I think just now he's out. I opened and he's out. No issues. Okay, but I think we are just into the winning zone. 11 runs of 17 balls needed. Great. ठीक है? चलो. Done है. Okay. What is the Fourier transform for xt equal to t upon 1 plus t square whole square? ठीक है? Yeah, correct answer for the previous one, Dreamer and Bhanu, it is C. Now, इस पे आ जाते. First, some basic properties can be applied here. Okay, t upon 1 plus t square का whole square. Okay, now recall what is the Fourier transform for e power minus a mod t. Important signals के Fourier transform तो याद रखना है. So for e power minus a mod t, Fourier transform is given by 2a is divided by a square plus omega square. 2a is divided by a square plus omega square. ठीक है? Right. Now if I put down the a equal to 1, I will get e raised to the power minus mod t having the Fourier transform 2 upon 1 plus omega square. From here I want to come to 1 plus t square. Step by step चलेंगे. Okay, from here I want to come to the 1 plus t square. To come to the 1 plus t square. Now how will I come to 1 plus t square? I want to convert the omega function into the time. Okay, and for that I will have to apply the duality. Okay, put down omega equal to t. It becomes a time function 2 upon 1 plus t square. This should have the Fourier transform. Okay, here I will substitute. This is equal to 2 pi x of minus omega. Here I will substitute t equal to minus omega. I get e power minus mod minus omega. Okay, what I have applied? The duality. इसको बोल दिया हमने duality. ठीक है जी? Okay, so let us rewrite this. Acha, ultimately modulus is an even symmetric function. Okay, so 2 upon 1 plus t square. This is having the Fourier transform equal to what? Okay, 2 pi e raised to the power minus mod omega, because this is an even symmetric function. What is the modulus of minus 1? It is plus 1. There is no sense of minus inside mod. ऐसा भी बोल सकते हैं, ठीक है? Now, but I want 1 plus t square का whole square. Denominator में square करना है. So the next idea is differentiate this. Okay, d by dt of 2 upon 1 plus t square. Differentiate this. D by dt of 2 upon 1 plus t square. Okay, this is having the Fourier transform equal to, okay, now derivative in time. Okay, the Fourier transform is multiplied by j omega 2 pi e power minus mod omega. Now we are almost done, because derivative of 1 by x minus 1 by x square. The derivative of x is minus 1 by x square, but chain rule, 1 plus t square derivative 2t. Okay, this has the Fourier transform 2 pi j omega e power minus mod omega. So for t, देखो one of the two will get cancelled. For t upon 1 plus t square का whole square, what is the Fourier transform? For the term t upon 1 plus t square का whole square, one of the two cancelled, another one two shifted on the right side, minus को भी right side पे shift करेंगे, तो you should be having pi j omega e raised to the power minus mod omega divided by the minus 2. Okay, अच्छा, better what is, you know, j को भी d से shift कर देंगे, because minus j can be written as 1 by j. Okay, so you will get it in the form of pi omega e power minus mod omega divided by 2j. Divided by what? 2j. Okay. Yeah, option number A. Option number A. Very correct answer is what? Option number A. Okay, fundamental Fourier transform property. One is the duality. Okay, and what is the next property they have tested here? One is the duality and one is the differentiation. Time differentiation. There are two properties. One is the time differentiation, one is the frequency differentiation. Here time differentiation has been used. Okay, ready with the next question. Consider a real valued signal. Consider a real valued baseband signal xt limited, band limited to 10 kilohertz. What is the Nyquist rate for the signal xt into x 1 plus t by 2? देखो, what is the bandwidth for the signal xt? It is having, okay, band limited to 10 kilohertz. Okay, that is 10 kilohertz. Okay, so for x of 1 plus t by 2, acha, x of alpha t plus beta, precedence rule, first shift and then scale, वैसे ही करेंगे. तो I only apply the shifting parameter. Okay, does shifting a signal affect the bandwidth? No. Does shifting a signal affect the bandwidth? No. Okay, now next, x of t by 2 plus 1. X of t by 2 plus 1. What should be the bandwidth? Now, x of t by 2. Okay, 1 by 2. Okay, so that means signal is getting expanded. Okay, A is equal to half. The signal is getting expanded. But if there is expansion in time, there is compression in frequency. Okay, as per the time scaling property. If there is expansion in time, there is compression in frequency. So bandwidth is going to become 10 is divided by 2. Because there is compression in the frequency domain, bandwidth will be becoming divided by 2 as per this given factor 2. Okay, so that is equal to 5 kilohertz. Now, when the two signals are multiplied, what is the bandwidth there? These are the basic results I hope you are aware about. I hope you are aware about. Whenever two signals are multiplied, actually, in time domain multiplication, so their Fourier spectrum will be convoluted. Na? There will be convolution in the Fourier spectrum, and convolution will add the duration, will add the bandwidth. Okay, so whenever two signals are multiplied, you can note down the final results. The bandwidth are added. The bandwidth are added. The bandwidth are added. Okay, so the net bandwidth is 15 kilohertz. So what should be the Nyquist rate? Nyquist rate is, okay, the twice of this, that is 30 kilohertz. Nyquist rate, we know, is twice of this bandwidth, so that is 30 kilohertz. Option number D, 2021 1 mark fundamental question. Because it is 1 mark, we have to have that 1 mark approach. We have to have that 1 mark approach. Always remember, guys, if x1t has some bandwidth, which is b1, if x2t has some bandwidth, which is b2, some important results when you add them. Okay, x1 plus x2. Okay, what is the bandwidth? What is the bandwidth? It is given by maximum of b1 or b2. whatever is the maximum. If they are multiplied, अच्छा plus minus दोनों पे same result चलेगा, but if they are multiplied like previous question I used, okay, if they are multiplied, okay, so they are convoluted in frequency domain, bandwidths are added, B1 plus B2, okay, but if there is convolution in time, if they are convoluted, so they will be multiplied in the frequency domain and then the bandwidth turns out to be minimum of B1 and B2. इस सबका proof है but अभी time नहीं है तो just you can note down. Okay, the bandwidth will be minimum of B1 or B2. The minimum of B1 or B2 when the signals are convoluted. When what? When the signals are just convoluted. Clear everybody? Okay ji, done hai? Done hai. Next question. Okay, so this is done, 30 kilohertz. Remember the important results. Okay, next one. Let MT be a strictly band limited signal with the bandwidth B and the energy E. Okay, assuming omega naught equal to 10B, what is the energy in the signal MT cos omega naught T? Modulation property. Okay, what does the modulation property says? Right, that if MT is having, there is a signal MT na, if MT is having some Fourier transform m omega, then MT is multiplied by cos omega naught T. This should have the Fourier transform m of omega plus omega naught plus m of omega minus omega naught whole divided by 2. Its spectrum, whenever a signal is multiplied by cosine, okay, its spectrum is shifted to higher frequency centered at plus omega naught and minus omega naught. Okay? And amplitude whole divided by 2. Now MT be a strictly band limited signal with the bandwidth B and the energy E. Okay, it is a band limited signal, bandwidth B, but for bandwidth we know only positive frequencies are considered. What is the signal that is not given? Suppose this is the m omega. Okay, but it is a band limited signal up to the bandwidth B and it has some energy E. Suppose this is the shape of the signal. Okay, suppose this is the shape of the signal. Bandwidth is B and for bandwidth only positive frequency are considered. That means it is from minus B to plus B and such a signal has been given an energy equal to E. Okay, okay, whatever may be the waveform, that exact waveform is not given, but yeah, it will have some energy content E. Now, for MT cos omega naught T, what is the Fourier transform? Okay, we'll sketch that Fourier transform and try to calculate this energy then. Okay, what is the Fourier transform for MT cos omega naught T? M omega plus omega naught, left shifting, M omega minus omega naught, right shifting, amplitude whole divided by 2. Okay, let us say this is some amplitude A. Okay, so now first of all it is going to be shifted at omega naught. But what is omega naught? Omega naught is equal to 10B, ye yaad rakhna. Okay, so it is going to be shifted at 10B, centered at 10B. So minus B plus B karenge. This will be going up to 11B, this will be going up to the 9B. Okay, other side it is left shifted to the point minus 10B. Okay, but same shape to be replicated, plus B minus B, so this should be minus 11B and this should be the minus 9B. Now what is the total energy content of this signal? They are asking what is the total energy content of this signal? What is the total energy content of this signal? So what is the energy of this signal? Now this is having the amplitude. If earlier amplitude was A, this will have the amplitude A by 2, this will have also the amplitude A by 2, but there is no change in the duration. Okay, so whenever the amplitude of a signal is multiplied by A, yeah, multiplied by some constant K, energy is multiplied by K square because energy is proportional to the square of the amplitude. Energy is proportional to the square of the amplitude. Okay, so what should be the energy here? It should be multiplied by half of it should be multiplied by square of half. Okay, and then what is the energy of this much signal? That is E. Okay, so that means it is E by 4. Similarly, what is the energy for this signal? That will also be E by 4. Okay, so what is the total energy? What is the total energy? That is E by 4 plus E by 4. That is given by E by 2. That is given by what? E by 2. Correct? Yes, dreamer. That is given by what? That is given by E by 2. And guys, you can also remember it as a standard result. Whenever a signal is modulated, its energy is halved. Okay. the energy content becomes half, that is the E by 2. That is known as what? E by 2. Correct answer is B here. Okay, the correct answer is B here. Chalo, moving ahead to the next question. Okay, again a good question that is going to involve some sort of modulation property, and it's a good question. 2023 EC 2 marks, current year EC 2 marks question. Okay, so let xt is equal to 10 cos 10.5 Wt be passed through an LTI system having the impulse response ht is equal to pi sin Wt by pi t का whole square into cos 10 Wt. ओके, फर्स्ट ऑफ ऑल इसको थोड़ा सा रीअरेंज करते हैं. क्या है ये? ओके, आई एम गिवन एच टी दैट इज इक्वल टू पाई, डिनोमिनेटर में पाई स्क्वायर, ब्रिंग इट आउटसाइड, पाई स्क्वायर, एंड रादर देन पाई आई वांट टू इंट्रोड्यूस w here, so that this is sin wt by wt, sin theta by theta sampling function. I can take it towards the sampling function and use Fourier transform formula. Okay, but there is no w square. Actually answer w square चाहिए, so I will multiply by w square and I will then divide by w square. Okay, so now it can be sin wt upon wt whole square. Okay, so that this w square can get cancelled into cos of, okay, 10 Wt into cos of what? 10 Wt into cos of the 10 Wt. ठीक है. Now this is the ht. Now dear recall, अच्छा इसको simple रखते हैं. So it is now equal to what? Pi upon pi cancelled, pi by pi cancelled, तो w square by pi into sampling square, sin theta by theta sampling into sampling square Wt cos of 10 Wt. ठीक है. Now what is the Fourier transform for sampling square? What is the Fourier transform for sampling square? What is the Fourier transform for sampling square AT function? For sampling square AT function, the Fourier transform, very important formula, ये याद होना चाहिए for rectant tri and for sampling and sampling square. It is given by pi by a. It turns out to be triangle omega by 2a. Turns out to be triangle omega by 2a. ठीक है. So what is the a I want here? It is w actually. It is w actually. So let us take it for this much part first of all. Okay, w square by pi sampling square wt का Fourier transform. W square by pi is a constant. So w square by pi multiplied both sides is now multiplied by pi by a. Here a means w. Okay, so pi by w into tri of omega by 2w, and that is equal to pi cancel, it is w tri omega by 2w. Now how do you sketch this tri signal? Okay, what is this much of the Fourier transform? This is not complete ht, but what is this much of the Fourier transform? Okay, tri of omega by 2w, tri of omega by 2w. Okay, a triangle signal from minus 2w से plus 2w and having the height of w, a triangle from minus 2w up to the plus 2w. Okay, but this is not the complete ht. Now I will multiply by cos 10t and then I will apply, because it is multiplied by cosine, I have to apply the modulation theorem. Okay, I have to apply the modulation theorem. Okay, so what is the ht? W square by pi sampling square wt cos of 10 wt, 10 है ना, cos of 10 wt, perfect, cos of 10 wt, but यहाँ पे 10.5 क्यों आ रहा है ऑप्शंस में? somewhere or the other, अच्छा because input, हाँ ठीक है, correct है, cos of 10 wt. Okay, now the signal is multiplied by cosine. Okay, so I will apply the modulation theorem. I will just apply the modulation theorem and draw its spectrum. Okay, the Fourier transform of the impulse response is known as the frequency response of the system. So I am now in a position to obtain what? I am now in a position to obtain the h omega. Okay, that is the frequency response. Okay, modulation apply करेंगे. So it will be shifted to plus omega naught minus omega naught. What is the omega naught here? 10w. Okay, what is the omega naught here? 10w. Okay, so once it is centered at 10w, it will be the same signal, but amplitude divide by 2. So it is w, there the amplitude will be w by 2, no problem. Okay, and minus 2w से plus 2w, so I will take it from 8 to 12. plus 2 this side, minus 2 this side. So 8W से 12W, and this amplitude should be W by 2. This height you can feel should be the W by 2. Similarly, symmetrically, left side minus 10W, 2 left and 2 right लेंगे. This will be minus 8W, this will be minus 12W. Freehand curve I am drawing, so don't worry about my drawing. Okay, now guys, this is the frequency response of the system. Okay, and why I want the frequency response? Because the input is given to me a sinusoid input, and I would check whether the frequency of the input sinusoid, whether it is within the frequency response or not. So what is the input? 10 cos 10.5 Wt. Okay, 10 cos 10.5 Wt. Okay, let me come to the input part now. Input xt is 10 cos of 10.5 Wt. It's like 10 cos omega naught t. Okay, so for a sinusoidal input applied, and if you know the frequency response, what should be the output? So what should be the output? It should be given by, okay, 10 is the gain of the input. The gain of the frequency response will be multiplied. Okay, the modulus of h omega naught, whatever is omega naught, I want to calculate the gain of the system into the input 10 cos omega naught t. Okay, so what is the value of omega naught? 10.5 W. Okay, तो यहाँ आ जाएंगे 10.5 W. This is what omega naught is, that is 10.5 W. Okay, what is the gain of the system at this frequency? What is the gain of the system at this frequency? निकल जाएगा, easily निकल जाएगा. Why you can calculate easily? Because for this particular line, let me write down what is the slope, and slope is given by height, that is W by 2, divided by the base. 8 से 12, base is 4W. So what is the slope? It should be 1 by 8. ठीक है? Oh, sorry, I'm so sorry. Okay, this line की बात कर रहे हैं ना, sorry. So it is equal to 2W. Okay, height W by 2, base is 2W. So slope is 1 by 4. Okay, now slope is height upon base. So let us calculate this height. Okay, suppose this is the height h. Okay, yeah, this is some amplitude, suppose A. This is some amplitude, suppose A. Okay, so 1 upon 4, it is also lying on the same straight line, so it will satisfy the slope of it. Okay, so height, it will satisfy A upon base. Okay, so what is this much of the base? इस triangle को consider करने का बोल रहा हूँ, तो how much is this much of the base? 10.5 to 12. 10.5 to 12, it is known as 1.5. 1.5 W. Okay, so what is the value of the amplitude? Okay, it is going to become 1.5 divided by 4 W. 1.5 is divided by 4 into W. Okay, I will go and substitute here. Okay, I will go and substitute here. 1.5 W is divided by 4. Okay, into the input 10 cos omega naught t, omega naught 10.5 W hai. Okay, so 1.5 into 10, 15. So my final output should be equal to 15 W by 4 cos of 10.5 Wt. Okay, 15 W by 4 cos of 10.5 Wt. 15 W by 4 cos of 10.5 Wt. Option number A. Please check it out. Option number A. 2023 EC 2 marks question. 2023 EC 2 marks, good question. So actually, you know, 2022 and 21 were little good question, little good paper for EC. This year 2023 we had little easier paper for EC, little easier, not much, but signals and EDC, 2-3 subjects were good. Okay, signals was good for this year also, 2023. Okay, signals के भी 4-5 questions were easy, 1 or 2 questions were on good side. This is one of them. ठीक है, चलते हैं next question की तरफ. All right. So I told you that whether it is good, easy, direct, moderate, however time it is, but I am discussing all questions of 3 years which I have promised. Next question की तरफ चलेंगे, and before going to the next question, let me also tell you that like regularly you are practicing on YouTube, but there are several practice sessions on the BYJU'S exam prep app also, and there are several practice quizzes. Okay, you can attend them daily at your convenient time. You can choose topics of your own interest. So, to gear up your practice, to enhance your practice for GATE, you can go to the BYJU'S exam prep app also and watch the practice sessions, or otherwise, other than sessions, you can directly attend the practice quizzes like a test form. Okay, daily some small quizzes. Okay, if you don't have the BYJU'S exam prep, get it on the Google Play Store, or there is a link in the description of the video. You can directly download using that link. Next question. 2023 EC 2 marks. Once again, the current year 2 marks question. Let an input xn have the discrete time Fourier transform. So now there is a question on the DTFT, discrete time Fourier transform. X of e power j omega. X of e power j omega is 1 minus e power minus j omega plus 2 e power minus j omega be passed through an LTI system. What is the frequency response of the system is also given to you, 1 minus half e power minus j omega. The output of the system is required, and output is in what domain? Okay, output is desired in, okay, it is desired in the time domain. चलो वो भी convert कर लेंगे, ठीक है. But at least in the frequency domain, see, what is the output? If you want to find in the time domain, that there is the convolution. Yn is equal to xn convolution with the hn. Or if you want to calculate in the frequency domain, DTFT में चले जाएंगे. So then property says that if two signals are convoluted in time, so they are multiplied in frequency. So x omega into h omega, and it's going to be a simple multiplication. Okay, let me first talk about y omega, and that is equal to x omega into x omega. Okay, what is the value of x omega? 1 minus e power minus j omega. Next है plus 2 e power minus j3 omega is multiplied by the h omega, and the h omega is given as 1 minus half e power minus j2 omega. So let me start multiplying it and rearrange the terms. Okay, so what should be y omega? Okay, सबसे पहले तो 1 से multiply किया, right? 1 minus half e power minus j2 omega. Okay, then minus e power minus j omega minus plus half e power minus j3 omega and 2 omega, ठीक है, plus the next term 2 e power minus j3 omega. Okay, and then 2 and half cancelled, minus आ जाएगा e power minus j5 omega. After simplifying, let me start with the DC term, and then okay, e power minus j omega minus e power minus j omega. 2 omega का एक ही टर्म है, तो minus half e power minus j2 omega. Okay, then for e power minus j3 omega, 2 plus half. Okay, 2 plus half, that can be written as 5 by 2 e power minus j3 omega, and then directly e power minus j5 omega with the minus coefficient. ठीक है, just check it out the calculation once. I think we have noted down all. ठीक है, यहाँ पे minus है, correct. Now guys, how to get the time domain signal directly? How to get the time domain signal? What is the DTFT formula? It is given by y omega. It is a DTFT of yn, so it should be given by summation of yn e power minus j omega n for all the values of n. That means, dear, I can write down y omega as, okay, the summation goes from actually minus infinity to the plus infinity. So sum of the terms, if you take like y of minus 1, if you take n equal to minus 1, it will be the e power j omega. Okay, plus y of 0. Okay, plus y of 0, n equal to 0 rakha, to e power 0, oh, that will be the constant term. Similarly, you will have the y of 1 is multiplied by e power minus j omega. Okay, n ka value 1 rakha. Then I will put down y of 2 e power minus j2 omega, and etc. 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 So I just need to compare them. I just need to do what? I just need to compare them. Okay, so if I compare, what is this? This is known as the y0. So y0 1 hai. Okay, with e power minus j omega, what will come is the value for y1. Okay, so I can say that y1 is equal to minus 1. Next, e power minus j2 omega. So this should be y2, which is minus half. Okay, this is known as the y3, which is equal to 5 by 2. And this is directly y5, which is equal to minus 1. The options are written in the form of impulse. Okay, the options is written in the form of impulse. Okay, so what can you check? Delta n, y0 is 1, so it should start with delta n. Okay, minus delta n minus 1. Okay, delta n minus delta n minus 1. Okay, next minus half delta n minus 2. Perfect. Okay, next plus 5 by 2. Next is the plus 5 by 2. That is going to be option number C actually. With this, I am able to match my answer and the answer is equal to C. Okay, with that I am able to match my answer and the answer is equal to the C. I'll just update about that, Bhanu. Okay. So guys, this is a very good question again. I mean, decent. It all depends on the approach. It's a decent question, I can say. Let's move ahead to the next question for this year. Quickly solve it up. This not this year. This is 2021, but again DTFT. Quickly solve it up. I shall be back in just a minute. Yes guys, okay. So I hope you have tried something. Okay. By Z transform, you want to talk about this question or previous one, Hari? Okay. So Bhanu, tomorrow's app class, as you are asking me, tomorrow's app class will be at 10:45 a.m. actually. Okay, 10:45 a.m. Okay, and it's a small topic only, Euler-Cauchy differential equation. 11:30 YouTube will be there. Okay, so tomorrow YouTube vector calculus 11:30 a.m. But that YouTube session is on the civil mechanical channel, our BYJU'S civil mechanical channel. Okay, so if you want to revise the complete vector calculus, I have 21 questions. Okay, through which you can entirely revise the vector calculus. That is tomorrow 11:30 a.m. I will share the link on Telegram. Whatever channel is, you don't worry, I will share you the link. You can directly join using that link and know about the channel also. Okay. Now consider a signal. Okay, that is 2 power n minus 1 u minus n plus 2 and yn is equal to 2 power minus n plus 2 u n plus 1. Okay, where un is the unit step sequence. Let x e power j omega, y e power j omega be the DTFTs. Okay, this is again on DTFTs. Okay, of xn and yn respectively. Okay, what is the value of the integral? What is the value of the integral? Okay, yeah, you can go for Z transform as well. Okay, you can go for Z transform as well. Okay, directly e power j omega you can convert into Z in that case. Okay, chalo. What is the value of the integral? 1 upon 2 pi integral 0 to 2 pi e power j x e power j omega y e power minus j omega y e power minus j omega. ये ध्यान रखना है आपको, ठीक है? So what I'm going to do here is, okay, xn, dear, pay attention. Xn has some DTFT x of omega. Okay, let us call the DTFT. I have the habit of putting this omega. Okay, yn also has some DTFT and that is given by y of omega. So what should be the DTFT of y minus n? Time folding property says that if there is folding in time, there is folding in frequency. So Fourier transform is y minus omega. That Fourier transform is y minus omega, which is coming up here. Okay, now let us say there is a signal Zn which is equal to xn convolution with the y minus n. Convolution with what? Y minus n. So what is going to be Z omega? Convolution in time, multiplication in frequency. Okay, so x of omega, y of minus omega will be multiplied. That is the term coming up here. Okay, अब देखो question में क्या पूछा गया है? The question is asking you 1 upon 2 pi integral for one time period x omega y minus omega d omega. That means the question is asking you 1 upon 2 pi integral 0 se 2 pi z omega d omega. And what is this? Acha, what should be the z omega formula? Hey dear, what should be the z omega formula? Yeah, actually IDTFT formula. Okay, we know what is the DTFT formula. यहाँ पे मैं IDTFT formula भी लिख देता हूँ. We all know that also. DTFT formula Zn is given by 1 upon 2 pi integral over one time period, integral over any one time period, z of omega e raised to the power j omega and d omega. So if I only have integral z omega d omega, that can be taken by placing n equal to 0, the area under the curve property. Okay, that can be taken by placing what? By placing the n equal to 0. So if you place n equal to 0, okay, this is nothing but z0. So what you only want is the value of z0. What you only want is the value of z0. Okay, now what is the zn? What is the zn? It is given by xn convolution y of minus n, and the convolution formula should be written as summation of xk, right? Summation of xk, h of n minus k, sorry, y of n minus k. Okay, यहाँ पे n will be replaced by n minus k, right? Okay, the summation xk, okay, y of minus of n minus k, okay, for k all values minus infinity to infinity. But dear, I only want z0, na? So why to solve the complete summation? Okay, I only want the value that is known as the value of z0, and z0 will be known as summation minus infinity say infinity x of k. What you have to put? N equal to 0, the n0 and minus of minus plus, so plus y of plus k. Now put down the value of both the signals that is given to you. So this is given by summation minus infinity to the plus infinity xk. Okay, what is the value of xk? Okay, xn is given to you, converted into k, 2 power k minus 1 u of minus k plus 2. 2 raised to the power k minus 1 u of minus k plus 2. This is the xk multiplied by the yk, multiplied by yk. So 2 power minus k plus 2, 2 power minus k plus 2 u of k plus 1. Perfect. Okay, but now unit step is involved, so we know that unit step is equal to 1 only when the argument is greater than equal to 0, otherwise the unit step is 0, and if you fit 0 here, if any of them is 0, answer will be 0. Okay, so we need to calculate the range. Minus k plus 2 should be greater than equal to 0, that means k should be less than equal to 2, but according to the second unit step, k plus 1 greater than equal to 0, so k greater than equal to minus 1. Okay, so if you combine these two, okay, if you combine these two, k should be less than equal to 2, k should be greater than equal to minus 1, matlab k is between minus 1 se 2, both inclusive. K is between the minus 1 se 2, that is both inclusive. So what should be the value for z0? Okay, what should be the value for z0? Okay, so now the z0 is given by the formula. Okay, summation minus infinity say infinity is removed. It is only going to be summation k equal to minus 1 up to plus 2 into 2 raised to the power k minus 1. Acha, 2 power k, 2 power minus k cancelled हुआ ना, so only 2 power minus 1 and 2 power plus 2. Okay, एक बार लिख देते हैं इसको, 2 power k minus 1, okay, minus k plus 2. So what is only left is summation of 2 raised to the power plus 1, which is constant. It actually doesn't depends on k, it is actually a constant. Whatever may be the value of k, it will be constant. Okay, so k equal to minus 1, k equal to 0, k equal to 1, k equal to 2. 4 values of k are there. Okay, so 2, 2, 2, 2 added 4 times. The answer for the question is 8. The answer for the question is equal to what? Is equal to the 8. The answer for the question is equal to the 8. The correct answer for the question is nothing but the 8. Okay, let's move ahead to the next. Okay, let's move ahead to the next question. Here it is. Consider a discrete time periodic signal with the period n equal to 5. Let the discrete time Fourier series representation is given DTFS. Okay, this is on discrete time Fourier series representation. Okay, is given to you. Summation k equal to 0 to n minus 1 ak e power jk omega naught, and this is the general format. Okay, the DTFS summation k equal to 0 to n minus 1, n equal to 5 है ना यहाँ पे. Okay, ak e raised to the power jk omega naught n, that is a general format. Okay, right, where ak are known as the discrete time Fourier series coefficients. These are the DTFS coefficients. These are what? These are the DTFS coefficients. ठीक है, चलो done. These are the DTFS coefficients. okay, ak, and e power jk omega naught n. Omega naught is the fundamental frequency which is given by 2 pi by n, 2 pi by 5, that is what is coming up here. Now what is the formula for DTFS coefficients? What is the formula for DTFS coefficients? It is given by the formula 1 upon n summation of xn e raised to the power minus jk omega naught n, okay, from n equal to 0 to n minus 1. ठीक है, तो यहाँ पे कितना हो जाएगा? Here the AK will become 1 upon 5 summation n equal to 0 से 4, क्योंकि n का वैल्यू हमारे पास 5 है, okay, x of n e raised to the power minus j k omega naught, which is 2 pi by 5, to e power minus j k 2 pi by 5 into n. Okay, that should be the Fourier series coefficient formula. Now they are asking, they have given some Fourier series coefficient a0, a1, a2, a3, a4, ये given है, ठीक है, ये given है. What is the value of the summation xn sin 4 pi n by 5? पहले इसको start करते हैं. What is the summation? देखो, question is asking you summation of xn n equal to 0 to 4 summation xn sine of 4 pi n by 5, and I will just break the sign by the Euler's identity. Okay, as per the Euler's formula, the sine theta is e raised to the power j theta, to e power j 4 pi n by 5, okay, minus e raised to the power minus j theta, okay, is divided by 2j, that is the Euler's identity. Okay, so this is then equal to 1 upon 2j को एकदम बाहर कर लीजिए. 1 upon 2j, the first term that is coming to you is, अच्छा, 1 upon 2j में, see, summation xn e power jk omega naught n और e power minus jk omega naught n can be compared with the ak, अगर आप 5 को यहाँ multiply कर दो. So what I will do is I will divide and multiply by 5. Okay, 1 upon 2j is outside, into 5 into 1 upon 5, okay, into 1 upon 5 summation of xn e power j, okay, 4 pi by 5n, okay, and the next one is minus 1 by 5 summation of xn e power minus j 4 pi by 5n. Okay, now please look, we have e power minus j 2 pi by 5 into n. ये 4 pi कब हो जाएगा? How can it be 4 pi if you take k equal to 2? If you take k equal to 2, so dear, this is 5 upon 2j. Okay, the second one is very clear. The second one is the formula for a of 2. Okay, if you take 2, this becomes 4 pi by 5. But the first one is plus 4 pi by 5. तो plus, देखो, ultimately 4 pi by 5, but plus कैसे आएगा? Okay, if you take k, not only 2, but you take minus 2, the minus will become plus. Okay, so that should be the formula for a minus 2. That should be the formula for a minus 2. But sir, what is a minus 2? A minus 2 nahi given. I am given a0, a1, a2, a3, a4. Guys, always remember DTFS and also the DFT. Okay, they are connected. The DTFS. Okay, the Fourier series coefficients. Okay, AK. They are always periodic. The Fourier series coefficients, the DTFS coefficients are periodic, okay, with the period equal to n. So that whatever is, I can say whatever is AK will be AK plus n. Will be always AK plus n. So using this periodicity, I can write down 5 by 2j. What is a minus 2? A minus 2 will be same as a minus 2 plus 5. Will be same as a minus 2 plus 5. So this part is equal to the 5 by 2j, a of 3. Now a minus 2 plus 5 is a3, and the value of a3 is given to you, dear. What is the value of a3? Now let us come to the question. a3 minus 2j and a2 is 2j. Okay, it is given by what? Minus 2j and then minus 2j. Okay, so 2j cancel. 5 into minus 2, minus 10 is my answer. Minus 10 should be the last answer. Please check it out, dear. Okay, good question. Properties hai. Okay, 2023 2 marks. Okay, the answer is minus 10, option number A. Everything depends on your practice and property. Okay, the signals You can only get command with lots of practice. You can only get the command with the lots and lots of practice only. Okay? So the answer is equal to what? The answer is equal to the -10. The answer is equal to the -10. Moving ahead to the next question, dear. Consider two 16-point sequences xn and hn. Okay, 2021 1-mark question. Let the linear convolution of xn and hn be yn, while zn denotes the 16-point inverse discrete Fourier transform IDFT of the product of 16-point DFTs of xn and hn. Okay, the values of k for which xk is equal to, for which zk is equal to yk. Okay, so what is yk? Okay, let the linear convolution of xn and hn be is equal to yn. Okay, so what is yn, dear? Yn is just the regular linear convolution, xn convolution with hn. Okay, but what is a zn? It is the IDFT of the product of the DFTs of xn and hn. ठीक है, अब देखो, let's say xn has the DFT xk. Okay, let's say hn has some DFT that is known as hk. Okay. Okay, now we need to take the product of the DFTs of xn and hn. Okay, product of DFT कब आता है? When you take the circular convolution of xn. Okay, in the DFT there is the circular convolution property actually. Xn circular convolution hn is given by xk into hk. Okay, so what is the IDFT of this? What is the IDFT of the product of this? ठीक है, I can say what is the IDFT of the product of the DFTs xk and hk. That IDFT they have called it as Zn, and that is xn circular convolution with hn. Okay, so understand the difference. Yn means the regular linear convolution and Zn means the circular convolution. Once again, DFT, if you want the full command, okay, you can watch my complete marathon session on the DFT around 2.5 to 3 hours. But in the very quick rapid fire manner, I have covered all properties, all shortcuts, all theory and variety of questions. It is available on the same channel. You watch it out. DFT fundamentals will be clear if you're not clear, because DFT, at least for EC branch, it is a fixed question. Mostly 2 marks, but sometimes 1 marks. But almost every year DFT or relating to DFT like DT, FS and all, almost you can assume the fixed question. Okay, so please, if you're not aware, you can watch that session. Okay, so what is the difference between them? The circular convolution and the linear convolution. So now what I can say, let xn, it is a 16-point sample, na? Suppose it is x0, x1, etc. up to x15, and similarly let hn is equal to h0, h1, etc. up to the h15, up to what? Up to the h15. Okay, so now what is the yn and what is the zn? देखो, okay, पहले regular convolution, the sum by column method, the tabular method. I'll write down x1 to x15 on one side, and on this vertical side I will write down h0, h1 up to h15. Okay, and now I will multiply first row with all elements x0, h1, x0, h0, x0, h1, etc. up to h0, x15. Then I will multiply h1 with all elements on the top, but 1 unit right shift I will write down the results. So h1, x0, h1, x1, etc. up to h1, x15, and I will keep doing it till the last mein it will be going to be h of 15 here, sorry, h of 15, x of 15, okay, h of 15, sorry, ये x15 नहीं, first x0 आएगा, h of 15 x0, h of 15 x1, etc. somewhere it will go h15 x15. Okay, and then I will do the sum by column, ठीक है. But when I am going to solve the circular convolution, देखते हैं, when I am going to solve the circular convolution, x of n, circular convolution with the h of n. So circular convolution may we apply, okay, the wraparound technique. Agar same tabular method, if this is used, the same tabular method, if this is used to calculate circular convolution also. So what will you do? No effect in the first row, h0, x0, h0, x1 up to h0, x15. But for the second row, you will again apply same h1 into x0, start 1 unit right. Now please pay attention. You will come to h1, x14, and what you did h1, x15, what you wrote here, na, that will be wrapped. Okay, don't go beyond this boundary. Don't go beyond this boundary, and whatever is the answer, please write it here on the remaining space. Similarly, H2 X0 यहाँ से start होगा. You will go up to H2 X13 and 14 and 15 terms जो right में जाना था वो यहाँ आ जाएगा. H2 X14, H2 X15. Okay. Similarly, last one. So see, last one H15. Okay, multiplied by X0. All other terms will be wrapped around and coming up here. Okay, so that will be H15 X1, H15 X2, and etc. Okay, wrap around. This technique is known as wraparound technique to quickly compute the circular convolution. To quickly compute the circular convolution. Okay. Now, when you sum by column, okay, which of them? Now see, when you add the first column here, it is totally different. Only one element. Here there are multiple elements. Second column, there are two elements here. But here all elements are there. So only which column can match? Only which column can match? See, H0 X15, यहाँ पे क्या आएगा? What will be coming up here? H1 X14. Okay, all these terms are same up to H15 X0. Up to H15 X0. Okay, so just you have to look into what? You just have to focus this particular column, this result, and this particular result. Okay, and what is this value corresponding to? Okay, what is this value corresponding to? Ab dekh lo zara. Okay, what is this corresponding value? Okay, this is the 15th from the beginning. So this is going to be what? Ye hai yn. Okay, this is y15 and here this is z15. So I can say that y15 is equal to z15. Only one possible value. Question में पूछा था, what are the values of k for which yk equal to zk? That is 15. That is only k equal to 15. You can now remember it. I have explained you the complete logic, but you can now remember it as a result. Only for k equal to n-1, circular and linear convolution will match. Otherwise, they will not. Right? Otherwise, they will not. ठीक है, मैं लिख देता हूँ. I'll write down this result for you. Only for k equal to n-1. Here n is equal to 16. 16 point signals are given. Only for k equal to n-1, the result of linear convolution will be equivalent to that of the circular convolution. Only at one point they will match. Rest all they will be different. Rest all they will be what? They will be the different. ठीक है जी, rest all they will be the different. That's it. That's it. Next question. 2022 last year EC 2 marks question. For a vector x, that is x0 to x7, be the 8-point DFT. Okay, and it's DFT for a vector x. The 8-point DFT is this capital X. Okay, and that is capital X0, capital X1 up to capital X7. Okay, where the DFT formula, which we already know, summation of xn e power minus jk omega naught n. Okay, omega naught is 2 pi by 8 because it is a 8-point signal. Okay, j is root over minus 1, ये भी पता है. ठीक है. Now the signal x means a time domain signal x that is given to you 1,000,2,000, 2,000. Okay, 1,000,2,000, 2,000, and y dash be the DFT of x dash. Then what is the value of y naught? What is the value of y naught? Okay. No, that is not equal. Okay, DTFT is a continuous function of frequency. DFT is discrete. Okay, the discrete version of DTFT is DFT, but fundamentally and mathematically there will be a lot of differences. Okay, chalo, ध्यान देना. So now we have DFT of x. ठीक है. So इसको हम xn बोलते हैं and its DFT. And इसका जो DFT है that is equal to capital X bar, suppose that is xk. Okay, so now I can say that xn has a DFT that is known as xk. Okay, that is known as xk. Now I want to calculate DFT of DFT. Calculate DFT of DFT. So I am going to again apply duality like in one of the continuous time Fourier transform problem I also applied. Okay, so in the duality, what we do? We replace k equal to n. Okay, we replace the k equal to n. We make a time function xn and that has the DFT given by n, where n is the points, number of points in the signal. Okay, into this value x okay, of minus k. Okay, so here we will convert it into the frequency domain, that is n equal to minus k, by putting n equal to minus k. Okay, that means this, okay, ये जो बोला है ना y dash dft of x, देखो this is the dft of x. Okay, now I am taking dft of, this is already a dft function, I am again taking the dft. So this is what should be known as, that y dash. Okay, or let me call it as yk, it's a function of k. Okay, this is what is the y dash. Okay, so the y dash, or that is known as yk, that is nothing but nx of minus k. Now folding here means of course circular folding. Okay, what is folding? Means circular folding. Okay, folding in DFT domain means circular folding. But हमें नहीं चाहिए ना result. What I only want y0. ये लीजिए y0 nx of minus 0, that is n का value 8 है. What is the value of x0? x minus 0 is x0. What is the value of x0? Complete signal भी निकाल सकते हैं, but right now let us focus on the answer. Okay, what is the value of x0? The first value, that is equal to 1. Okay, and so the answer is 8. Question is complete. Answer is 8 and the question is complete. That's it. Okay, but if you want a complete answer, okay, if you want a complete answer, I will write it for your sake. As I told you, it is given by nx of minus k. Folding for periodic signal always means the circular folding. And how do you solve for the circular folding? Okay, how do you solve for the circular folding? What is the x vector given to you? 1 000 2 000. Okay, always separate out the origin value and then place a mirror at n by 2. Place a mirror at n by 2. This is n by 2 because it is going to be the 4. 0, 1. We start the counting from 0. Na? So 0, 1, 2, 3, 4. Place a mirror at 4 and swap the values about the mirror. But here it is a symmetric signal. Okay, so even if you take the mirror image, n का value 8 है. Even if you take the mirror image, 1 को तो separate किया. Okay, whenever you take the mirror image, there is no effect on the mirror. Na? Mirror will be as it is. Left goes to right, right goes to left. Okay, so this portion and this portion should be swapped, but they are identical here. Okay, so even after swapping, it looks like same. It looks like same here. Okay, so the complete answer for the vector y bar is 8 000 16 000. It is 8 000 and the 16 000. Clear? It is known as the 8 000 and the 16 000. 8 000 and 16 000. So anyways, our answer was only y0. That is why I stopped at the short result. Okay, that is the answer. 2022 EC 2 marks 8. So I'm telling you, DFT you must be prepared, especially for EC aspirants, because almost every year fixed question, most likely 2 marks, but sometimes 1 mark, but almost 99% chance that DFT you are getting a question. Okay, at least the EC guys. Okay. So that's it. All questions of 2021, 22 and 23 discussed today, right? And also now the time to tell you the PDF password, and PDF password, here it is, simple one. The PDF password for today, okay, is a very, very important topic, DFT. Okay, place this as the password, DFT. Yeah, काम करेंगे as we normally write it as, let us put it in capital so that you are not confused. Okay, I will share you the PDF of the session with all questions, concepts, solution, discuss, everything written, okay, in my Telegram group, but only those who watch the session, they only need the PDF. Okay, fair enough. So those who have been watching, guys, you get the PDF, you deserve it up, and the password for the PDF will be DFT, capital DFT, randomly framed password it is. Okay guys, and also guys, if you want to have the complete syllabus coverage, if you're one of the students starting preparation right now but still want complete syllabus preparation, in the remaining time the crash course is live for you. That will offer you live classes, also recorded lectures available, study material, mock tests and practice quizzes, okay, with your favorite faculties. And also guys, for any more details about the course like timings or fees or faculty details, anything, you can contact 924-133-666, okay, and get all your doubts rectified. Okay, also guys, to enroll in any of the course like crash course or the full-fledged course, Okay, the national scholarship test is there for you this Sunday, that is 24th September, just 2 days ahead. Perform well in the scholarship test, and based on your performance you can get up to 90% scholarship. So this is on the BYJU'S exam prep app. And also guys, on the BYJU'S exam prep app, on the coming Wednesday, 27th of September, this is Wednesday at 7:30 p.m. Okay, all your favorite Richa madam is bringing you a free live interactive workshop. Okay, last 120 days preparation strategy, very important. You might have prepared a lot till this time, but last 3 to 4 months, how to balance your preparation, how to capitalize on preparation, all those things, okay, will be delivered by Richa madam to you on the Wednesday 7:30 p.m. Okay guys, chalo, I shall share the link. Yes, like this EMFT is also there. I'll update you. See, now next PYQ session I am going to take on Monday. That is again signals only. Okay, that is only signals, but double E questions we will discuss. In that first we will discuss what? We will discuss the double E questions. ठीक है? Double E के questions को discuss करते हैं वहाँ पे. Okay, then Wednesday, okay, we will discuss EMFT. Okay, right, Wednesday and Friday. Okay, Wednesday and Friday EMFT. Again branch wise we will split. Okay, Wednesday and Friday we will discuss the EMFT questions. ठीक है? That is how we are going to break it up. That is how we are going to break it up. Done hai ji? Okay, done. Okay, so Monday signals, like this double E questions we will discuss. Chalo guys, and those who are not connected with me on Telegram, I shall just quickly share you the link of Telegram, and then we are going to close the session here.